Hello, class. I'm going to go over section 5.1, probability distributions for the statistics course, and this will be part of test number 3. And so it talks about vocabulary. It starts off with a random variable. A random variable is a variable whose values are determined by chance. Variables are associated with probability. And then this probably looks familiar from one of our previous quiz material. Quiz 1. So it talks about data, how data is broken into both qualitative and quantitative. And under the quantitative, it talks about it being numerical and it can be ranked. And then quantitative data is also further broken down into discrete and continuous variables. And so I'm going to add the word variables to this here. So discrete variables and continuous variables. So discrete variables are countable, and they have some examples of some counting numbers here. Continuous variables, they can be decimals and they can be fractions. And they have some examples here of some decimals listed here. And also, to distinguish between the two with discrete variables, we want to write this. Discrete variables can be enumerated using counting numbers, 1, 2, 3, and so forth. So the word is enumerated using counting numbers. Like 1, 2, 3, and so on and so on. Whereas continuous variables, these are measured using an instrument. Okay, and then at the top, I'm going to give you, I have lots of open space here. I'm going to give you an example of each. And on your test, when we take test number 3, you'll be given a scenario or a description, and you'll be asked if it's considered a discrete or a continuous variable. And then you'll want to have a little justification, a little written justification as to why it is. So remember on your test, your test might be mostly multiple choice. There'll be a few fill in the blank, but remember on your multiple choice, you would circle discrete or continuous, but on your paper, on your template, you would have to justify and write a sentence or two to justify why you went with that answer choice. Okay, and that's where you get your full points on the rubric. Okay, so at the top, here's an example of discrete. So here I'm going to say the keyword is the number of. Okay, so it says the number of cheeseburgers served each day at a fast food restaurant. And I won't put a period because it's not really a sentence with a subject and a verb. It's more like a participial phrase. And the key word is the number of. So oftentimes with discrete, they'll have that, the number of something, the number of. And this is considered discrete because cheeseburgers are countable. So uh, justification. Okay. Okay, now an example for continuous. So an example for continuous would be the blood pressures of all patients admitted to a hospital on a specific day. And then your justification for that would be that measuring blood pressure requires an instrument. Right. So you know that when they come in, they measure your blood pressure, like in a doctor's office, the nurse has some kind of a little uh, a stethoscope, right? Or some kind of a measuring gauge, right? Where they have to put, yeah, it's some kind of a measuring gauge too, where they have to put something around your arm, right? And then they pump that and they count. So they're counting, doing a count, right, to measure. So they have some kind of an instrument that they use, or a couple of instruments maybe to help you measure the blood pressure. Okay. Take that reading. Okay, so they just don't count. They just don't do a sole count like with cheeseburgers. You don't need a special instrument to do that tally. You just count on your fingers and keep track of that. Okay, so that's how you distinguish the two from whether it's considered continuous or discrete also. Okay. All right. Okay. And then it talks about a discrete probability distribution. So now we're talking about what are some examples of that, or what does that consist of? It consists of the values a random variable can assume and the corresponding probabilities of the values. Okay. And so it says let's revisit the idea of tossing 3 coins and what would be the sample space for that. And then you would let X be the random variable for the number of heads. Okay. And so we're interested in the heads. So you can see how they have here number of heads, um, and you're rolling 3 coins. So I think I happen to have 3 coins here. And they're saying that either you land on this one over here says 3 heads, 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 or you land on all tails. That's the first one. Tail, tail, tail. Or you might have a couple of heads, right? So it's first coin, second coin, third coin. So the first coin is a tail, and the second coin is a head. And then the third coin, let's see, actually, this one's tail, tail, head. So tail, tail, heads. That would actually be the first one. Tail, heads, tail. Okay, that's the second thing that can happen. Or head, tail, tail. So these are all the different things that can happen. So this is one, and the denominator here is, I'm not sure if you can see that, it's really small, but that denominator is a total of 8, right? Because there's 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's really small, but this is 1 out of 8. This is 3 out of 8. This is also 3 out of 8. This is 1 out of 8. Okay. And if I figure those values, let's see what 1 divided by 8 is. 1 divided by 8 is 0.125. Whereas 3 divided by 8 is 0.375. And then these are identical. See, 3/8 and then 1/8. So you know those are the same values. Okay. And you know, they said the total was 8. So if you remember me talking about this here, where if I were to do 2 cubed, 2 representing, you know, either the heads or the tails, and then 3 being you tossing a coin 3 times. Okay, so that gives you 2 times 2 times 2. So 2 times 2 is 4, and then 4 times 2 gives you 8. So there's your total outcomes. Remember we said the denominator was 8. Okay, so that gives you an idea of how many you'll have. Okay. Um, and so the idea when you do these, these are successes. So like what's desired, in this case we wanted the heads over the total outcomes, and there was 8. So our denominator was 8. And we're interested in the heads from rolling 3 coins. Okay. Now, when you make oh, I was also going to do this on here. So I'm also going to associate a number at the top, number of heads. So this would be 0, 1 head, 2 heads, 3 heads. Okay. And when you make a probability distribution, one of these discrete probability distributions, I'm going to do that down here. Because it says a corresponding discrete probability distribution is. So I'm going to go ahead and draw this line here. And this is X. This is your random variable for the number of heads. And then this is your probabilities. Which we'll call P of X. And so here's that number 0 that we talked about. And remember 0 was 1 over 8. Okay, so that was 0.125. Then we had 1, which that was 3 out of 8. And that was 0.375. And then we had 2, that was also 3 out of 8. And then we had the last one was 3, and that was 1 out of 8. Okay. And when you create these to kind of to check your work, there are 2 requirements. One of them is that when you add up all the probabilities, it's supposed to equal exactly 1. So if I do a check here, and let me just close this here. And let me close this here. Okay, so if I do a check, I can do this. Summation, that's a sigma summation probably of X. So I have P of 0, which is 1/8 if I stick with the fractions, plus probability of 1, and that is 3/8, plus probability of 2, and that is also 3/8, plus probability of 3, and that is 1/8. So when you add fractions, you have to have a common denominator. Otherwise, you have to find it and build it up. So if I add this, all the numerators, and I keep it all over 8. So that's 4, 5, 6, 7, 8. Yeah, and then 8 over 8 is 1. So that meets the first requirement. The other requirement is that each probability has to meet the definition. So you're going to use the definition on your test when you take that test 2. Each of your probabilities. So like P of 0 happens to be the same value as P of 3, which is 1/8, which is 0.125. And that's a number 1/8.125. That's a number between 0 and 1. This is about 13 cents, right? If you think about money, 13 cents, 0.13. That's between 0 and 1. So you can't have any negatives, and you can't have anything over 1. Also, if it were percentages, it couldn't have anything over 100%, right? And no negatives. Okay, and then also these 0 between P of 1, which is equal to P of 2, which is equal to 3 over 8. So that's the value 0.375. Oh, no, that's also met. Okay. Okay. So there's your random variable here was for the number of heads, okay? And these are our probabilities for that, okay? And the definition, I don't know why the definition's on the last page. It really should have been on the first page, but what I just did is the 2 requirements, for some reason they put it at the back. So what I was doing back here, 2 requirements for a probability distribution, that is when you sum the sum of the probabilities of all the events in the sample space must equal exactly 1. So that's what I just showed. We added them all up and got 8 over 8, which is 1. And then the probability of each event in the sample space must be between or equal to 0 and 1. See these little bars? So underscores between 0 and 1 inclusive. So no negatives nothing over 1, nothing over 100%. Okay, so that's what I was showing. Okay, so those have to be met. Okay, now on the next page, rolling a die. So construct a probability distribution for rolling a single die. Okay, so I'm going to do the same thing. I'm going to put, draw this up here like I did earlier. X is a random variable. And this is for rolling one die. And then this is going to be P of X, which is your probabilities. Okay, so, and I happen to have a die right here. So one thing that can happen when you roll a die, has 6 sides, it could land on one dot, right? Okay, and that's going to happen 1/6 of the time, right? Because there's 6 sides, and 1 divided by 6 is a repeating decimal, 0.16 repeating. Okay. All right. Okay, or you could roll it on a 2 here. Okay, and that's only going to, and all of these are only going to happen one time because a die has 1 through 6. So all these are all going to be 1/6, all of them. Okay, which is 0.16 repeating. Or it could land on a 3. Could land on a 4. Could land on a 5. Or it could land on a 6. These are all going to be 1/6. Okay. So really, you know, these up here are like your sample spaces, right? Your sample spaces. Okay. Okay. All right. And again, if I do that test, like, remember the requirements are that when I add them all up, all the probabilities, it's supposed to equal 1. So the good thing is these are all repeating. So if I show that here, let me close this and close this here. So if I set it up this way, summation probability of X equals, and I can do this 1/6 times 6 because there's 6 of them. So I don't have to write 1/6 plus 1/6 plus 1/6 over and over 6 times. I just write 1/6 times 6, and then this is just 6 over 6 because you multiply straight across. 6 times 1 is 6. 6 times imaginary 1 is 6, and then 6 over 6 is 1. Okay, and then each one, see, each one is about, if I round that off to like 17 cents, so each one, it meets this requirement, probability of 1 through probability of 6. These are all equal to 1/6, which is about 17 cents, right? 0.16 repeating. and that is all between, see, it's all between 0 and 1. So P through 1 through P6, they're all equal to 1/6, which is about 0.16 repeating, about 17 cents. It's between 0 and $1, right? 0 and 1. That is all met, okay? And that way you're showing that this is being met. Are all of these between 0 and 1 inclusive? Yes, they are. Okay, and that's one way to write that. Okay, so that meets the requirement. So this is correct where we set that up then. Okay, and then you can also draw a picture, a graph, represent the graph of your probabilities, but they want you to put the graph for tossing 3 coins. So you really, they should have had these problems kind of switched, because this picture that you have here is going back to this one here with the 3 coins. So your probabilities, look where your probabilities are at right here along your, like your y. Think of this as your y-axis. They call it p of x, probability. And then over here is your x. It's your random variable, right? Your random variable x. And this was, see, the number of heads. See the number of heads. So no head, 1 head, 2 heads, 3 heads. See, so 0, 1, 2, 3. So this 0 went up to 1/8. See, so you have 1/8, 2/8, 3/8. So at 0, it was 1/8. At 1 head and 2 heads, remember they were the same? Those were 3/8. And then back down to 3 is 1/8. Okay. Now the thing is that your book, when you look, and I'm hoping you're reading your ebook, it's important for you to read your ebook to supplement what I do in class. A lot of times I'll take things that I write, vocabulary verbatim from the book too. Um, but it's still good for you to read your book. So you'll notice in your book that they actually don't make the graphs like this. They actually, when you look through your book and you look for pictures, they actually do this. Okay, so this is X, and I'm going to put here number of heads. Okay, so, and then I'm going to do 0, 1, 2, 3. And then here I have 1/8, 2/8, 3/8, 1/8, 2/8, 3/8. Okay. And let's see. And then on the side, I'm going to put P of X for probabilities. Okay. All right. And then this is how it's different. You'll see in your ebook when you look for pictures, they draw just a thin line segment or line. For 0 was at 1/8. So 1/8 is right here. So they just do this. They do that. And then 1 was 3/8, and so was 2. So 3/8 is like over here. So they do this. Okay. And then 3 is 1/8. So they do this. Okay, and that's really how they draw these up. Okay. it's as opposed to the bottom. Okay, so just keep that in mind. And you might have to do some on your homework. You might have to do some on your homework. Before then, now they have the enhanced Connect Math, but before that the students would have to draw something like that and pick up their line segments. So you might have to do something similar. Okay. Okay, then we have page 128. And I wish I'd left these blank so we could fill them in, but I don't know why they didn't leave them blank. But it says here that the probabilities that a customer selects either one, two, three, four, and five items at a convenience store are respectively these probabilities. So X here, let me extend this out. They didn't put the description here. They just put X, the random variable, and then P of X, you already know that's probability. But X, I'm going to put here number of items selected at a store. Number of items selected at was a convenient store. Okay. Okay. Convenience store. Okay. So my dad owns a little convenience store since he's retired in the valley, Rio Grande Valley. And my parents are there in the valley, but runs a little convenience store there. But because of the pandemic and COVID, has had to close a store. And so, but he was enjoying that, in his retirement, running the little convenience store and just selling things like, soda pop and beer and smokes and things like that, tobacco, things like that. Um, but it keeps him busy and keeps him out of trouble with mom at the house. Okay. Anyhow, so hopefully he's doing fine because the pandemic's going on. He can't run his little store in the meantime. So hopefully he's okay at the house there. But just thinking about him because this problem is talking about a convenience store. Okay. So so when the customer selects one item, the probability is 29 hundredths. When the customer selects two items, it's 11 hundredths. When the customer selects three items, it's 16 hundredths. And when the customer selects four items, it's 16 hundredths. And then when the customer selects five items, it's 18 hundredths. So if I do that little test, um, probability, the summation of probability of X equals probability of 1, which is 29 hundredths, plus probability of 2, and that was 11 hundredths, plus probability of 3, which is 26 hundredths, plus probability of 4, which is 16 hundredths, excuse me, plus probability of 5, which is 18 hundredths. So when I add those up on my calculator, I'm supposed to get exactly 1 if this is correct. That's the requirement at least. So let's see. So if I add 0.29 plus 0.11 plus 0.26 plus 0.16 plus 0.18, you see how you get 1? See that? And so this is equal to 1 as required, okay? And then the other requirement is that each one has to be under $1, right? Between 0 and $1. No negatives. There's none of these are negatives, and none of these are over 1. So if you were to write that up, you could say, for example, so you have these 0, P of 1 is equal to 29 cents. See? And that's saying that that's each, you'd have to do that each one is between 0 and 1 inclusive. So they're none of them repeat. So it can't be quick like the other ones they were repeating. These are all different. So you just have to be patient when you demonstrate that. But you see you're demonstrating that 11 cents is under a dollar, right? And the P of 3 is 2,600. That's under 1. I'm just using money as a comparison. But yeah, it's between 0 and 1. Okay. So you just have to be patient, but that's demonstrating this requirement that each probability has to be between 0 and 1. Whereas the first one demonstrates this. If you sum all the probabilities up, all of them, it gives you exactly 1. So it does meet the requirement. Both of them have to meet. If one of them doesn't meet, it can't be a probability distribution. And of course, if both of them don't meet, it's not a probability distribution. Okay. Okay. And then we were talking about the graph. So you do see the graph here. Do you see the graph here? Um, and um, and I don't know, in they have done the connect math with the enhanced model. So I'm not exactly sure if you'll have to be doing this again on the computer, but you used to pick up a segment. Like for one, you would grab with your mouse and highlight this, pick up this segment. And for one, it's 29 cents. So you can see here, this is 0, like a dime, 10 cents, 20 cents, 30 cents, 40 cents, 50 cents. So the 29 cents, you can see it was really light, but 29 cents is just under 30. So that one should come all the way up to here. It's just under 29 cents. It's just under 30. So it should be really close to that. And then for the 2, it's 11 cents. So just a little bit, this is 10 cents. So just a little bit over. So you would have to drag this, right? So for 1, you pick this up and drag it. And for 2, highlight this, pick this up and drag it with your mouse. For 3, it's 26 cents. So see, that's about right here. So here's 20 cents and 30 cents. So they put it about right there. And then for P of 4 is 16 cents. So put about right here. And then probably a 5 is about 18 cents. So they put about right there. Okay. Okay, so if you wanted to, that's this is the 29 cents. This is the 11 cents. This is the 26 cents. This is the 16 cents. This is the 18 cents. Okay. Okay, and now we're going to do some extra problems here. We're going to use our vocabulary. Let's see. So let's do this. So let's say that we were finding the probability of 3 or more. Okay, so probability of 3 or more would be starting here, 3, 4, 5. And then that's all, you don't have any more, but you've got to go 3 or more, 3, 4, 5. So you would have to do probability of 3, and that has a value of this, which looks like 26 cents, plus probability of 4, and that looks like it has a value of 16 cents, plus probability of 5, which was 18 cents. And then when you add those on your calculator, 0.26 plus 0.16 plus 0.18 is 0.6. Okay. Okay, let's do another example. Find the probability of exactly 2. Okay. Okay, well, that would be just P of 2. Exactly 2 is just that one, which is 11 cents or 0.11. Okay. Okay. So just remember in your work just to be patient and show your work. So don't just jump to this. I can't read your mind. So put your steps in for your vocabulary. Okay. Okay, let's do another one. Let's do one more, but this one has to do with a definition. Let's go back to this definition that we saw from previous chapter, chapter 4. Probability of A or B is equal to probability of A plus probability of B. Okay, and this is using the addition rule. Number 1, these would be considered muy, as I say, mutually exclusive, muy events, because they won't overlap. They won't overlap, they won't share, okay? So they're exclusive, okay? And so these probabilities won't they won't be able to, you can't mix these probabilities, okay? So an example of that would be find the probability of 2 or 3, okay? So that's going to be equal to the probability of 2 plus the probability of 3, okay? So probability of 2 is the 11 cents, and the probability of 3 is the 26 cents. Okay, so then when you add those up, 0.11 plus 0.26, that's 0.37s. Okay, so remember with this mutually exclusive, we say that you just add the outcomes and no need to subtract because no overlaps. Okay, so that's why we're not subtracting anything here. Okay, so that's kind of cool. See how your vocabulary fits with that. Okay, and then there's one more page. One last page for 5.1. Okay, so if you're ever not done recording, you can always pause your video, and then record that. Okay. Okay, I'm gonna keep going before I start yawning, getting sleepy. I apologize. I get sleepy, I yawn. Okay, here we go. Okay, so this one has 4 examples, and I don't do all 4. I just do 2. I usually do A and D. And this is kind of like what we're doing before. Determine whether each distribution is a probability distribution. So you would have to check for both of these, okay? And so, and even if one fails right away, I still want you to check both of them. I want you to tell me if it fails because one of them isn't met or both of them. So I want the status of both of them. I want you checking both statuses, and then tell me their update, whether they pass or not. So this first one, and this is also interesting. Notice how it doesn't always have to start at 0 or 1. See, this one starts at 5. And also, this is not in order. It doesn't say 5, 6, 7, 8, 9. So it doesn't have to be in order. But what you notice about the X, the random variables, you're noticing that they all can be like whole numbers and counting numbers. They can start with 0, but these are whole numbers and counting numbers. You don't see you won't see like any negatives for X or any fractions. These are all counting numbers. Okay, so just keep that in mind. Okay. And so on A, so we're going to do A. So for problem A, um, checking 1. So what I mean by 1 is this, see, 1 and 2. So I'm checking 1, which is this. Summation of P of X equals 1. I'm going to check that. Okay. So I'm going to start summation P of X is equal to, and I start with this, see, P of 5, which is 0.2, plus P of 8, which is the value 0.6, plus P of 11, which is the value 0.1, plus P of 14, which is the value 0.3. All right, so then I get my calculator and then I'm going to add them up and hopefully it equals 1. I need it to equal 1. 0.2 plus 0.6 plus 0.1 plus 0.3. Uh-oh, it doesn't equal 1. It equals 1.2. Okay, so Houston, we have a problem, right? There's an issue with that. So you need to convey that. You need to tell me that the summation of P of X equaling 1 is not met for problem A. And that's an issue right there. That tells you that therefore this is not a probability distribution. So problem A is not a, and look at the title, probability distribution. Okay, now I don't, just because of that, I don't want you to stop there. I still want you to check out investigate 2. And so I'm going to say we still, excuse me, need to check number 2. And number 2 says that each probability has to be between 0 and 1, each one. Okay. And then, so what we can do for this one, we can do 2 things. You could also do a picture. So if you want, you could draw a number line. And then you can draw here 0. And then here's 0.5. And then here's 1. Okay. And then you have, see, 20 cents, which would be, let's see. So let's see, it'd be about, I have 10 cents, 20 cents, 30 cents. I could do that. So this is like 10 cents and then 20 cents and then 30 cents. And then, so you have 10, 20, 30, and then 60 cents. 60 cents. Okay. So yeah, those meet this. These are all within, you see the underscore, see? That's why I put a bracket, not parenthesis, bracket. These are all between 0 and 1. So that would be fine. Or you could um and this is like okay. This is okay. So let me see. We'll write um okay, we'll say that this right here, this here. So we need to check this one. And this one is met. This one is met. Okay, so I wrote it down somewhere. Okay. Or what you could do is each one do it separately like this. P of x, no, P of 5, right? P of 5 equals P of 5 equals zero point 0.2, and that's between 0 and 1. And P6 is, or excuse me, P8. P8 P8 is 0 0.6, which is between 0 and 1. And P11 is 0 0.1, which is between 0 and 1. And P of 14 is 0 0.3, and that's that. So you could show it like this is met, or like this, but these are still showing that they're met. Okay. All right. So this one's met. Okay. So even though this one's met, it's still not a probability because the first one, number 1, wasn't met. Okay. And that's fine. Okay. So you're still checking. Okay, now let's do D. Let's do D now. Okay. So D, so for problem D, again, we're going to checking number 1, which is summation of P of X equals 1. Okay. So you have summation P of X equals, and you start with P of 4, and that is a negative 0.5 plus P of 8, which is 0 0.6, plus P of 12, which is 0 0.4. Okay, so let's add those up. Let's see if that gives us 1. So negative 0.5 plus zero point 0.6 plus zero point 0.4. Uh-oh, that does not give us 1. That gives us 0 0.5. And it's supposed to equal 1. Okay, so you want to say the summation of P of X is equal to 1 is not met for problem D. Okay, so what does that tell you? That tells you that problem D is not a probability distribution. Okay, but that doesn't mean you stop there on the test. I still need you to check number 2. We still need to check 2, which is to check each probability and to see if it's between 0 and 1. Okay. So again, you could do the number line. You could draw a number line. I think I like that idea. I didn't do that earlier on the other pages when I did that. But that's an idea. So you can draw a number line, and then you can draw here. Here's 0. Here's 0 0.5. and here's 0, 1. Okay. And the first thing you see is, uh-oh, look at this, negative 0.5. That's outside of this. So that's like somewhere out here. Negative 0.5. That's like right here. Yeah. And I think what I should have done over here is I should have put little beads here, right? So I should have done like this, little beads here. Yeah, I should have plotted them with little beads there. Okay. Okay. So here I put a little little point for that. And that's not good. Let me just check out the other ones. 0.6 would be about right here. 0.6. And then the other one is 0.4, which is about right here. Okay. But this is an issue right here, right? That's a trouble spot right there. Okay. So you need to document that. You need to document that. So you need to say that um, what was it? It was that represents which one? P of 4? P of 4, which is equal to negative 0.5, does not meet this. Okay, so this one's a problem. The one with the negative does not meet this. Doesn't meet it. Okay. But the other two are okay. So this one you put like an X on that. But these are okay. This one 0 P of 8 is equal to 0.6. So that's good. And then you have a check mark on the other one. The other one is P of what is that? 12? P of 12, right? It's 0.4. Yeah, put check mark. That one meets that. But this one doesn't. Okay. And so we already said that it's not a Probability distribution. Um, it's still not going to be a Probability distribution, but we also know that because this is not met. Okay, so it's kind of not a, it's not a Probability distribution for two reasons. One, it violates the first requirement and it also violates the second requirement. So does not meet this. Okay, and that'd be fine. Okay, so it violates both of them. But you're letting me know. You're letting me know you're checking that. Okay. All right, so go look on this homework set then, okay? When you get ready to do 5.2 and 5.3, there is an extra handout that you're going to want to print that's supplementary to the workbook. So you want to print that extra sheet out, okay? We'll get ready to do those 5.2 and 5.3. It's in your module, your next module, I think module 8, I believe, for test 3. Okay, good luck with that.